Well, hey there, kiddos. Let's talk about applications of polynomials. So we're basically just going to take what we've been doing for the last couple of weeks and put it all together with some application problems, which means words. Words, words, words. So we got 4 examples we're going to go through, and I'm going to try to go through them pretty quick because I don't want this video to be too long for you. So the first one, you got a rectangular bedroom. That tells me I need to draw a picture of a rectangle. It has a length of x plus 3 and a width of x minus 1. We want a polynomial in simplest terms to express the area. Y'all have seen problems like this before today. Area of a rectangle is length times width. So we're going to multiply these two things together because I've got a binomial times a binomial, and I'm going to do the distributive property thing. So x times x makes x squared. X times negative 1 makes negative x. 3 times x is 3x. And 3 times negative 1 is negative 3. So I will combine my two middle terms here and end up with x squared plus 2x, because negative x plus 3x makes 2x, minus 3. This is your polynomial in simplest terms for the area of the bedroom. Now, to calculate the area, you got a couple of options here. And y'all are pretty good at this. Anytime I've seen y'all have to do a problem like this, I've seen y'all just take the 10, plug it into here, and do the math. That's great. You can also take the 10, plug it into this polynomial you just made, and find out the area. I'm going to do that. But if you want to plug it into here and then do length times width, go for it. I don't care. Same thing. So I have x squared, so I've got 10 squared plus 2 times 10 minus 3. That's going to give me my area. Well, 10 squared is 100 plus 20 minus 3. Well, 100 plus 20 is 120, and 120 minus 3 is 117 square feet. That is the area of the room. And so that's how you do that. Now, here is something that I have seen you guys do, and so I want to make sure that you are understanding this. We get this part okay because you understand that you can plug 10 into here, these two polynomials, and do length times width. You're good with that, part B. It's part A where I've seen mistakes. When it says to write a polynomial in simplest terms, you cannot just write this part, x plus 3 times x minus 1, and stop. You have to actually multiply those out. Otherwise, it is not in simplest terms. Excuse me. So please make sure that you multiply those together. This is not a polynomial in simplest terms. That's just simply the multiplication problem you need to do to solve it. So here's our next problem. Question number 2 here is about 2 cabins that are on opposite banks of a river. They are 12x squared minus 7x plus 5 feet apart. So the polynomial from here all the way to here is this. On the same path, one cabin is 9x plus 1 feet from the river. So from here to the river is 9x plus 1. That's just this distance right here. The other cabin is 3x squared plus 4 feet from the river. So the distance from here to here. We have to, part A, first of all, write an expression in simplest terms for the polynomial that represents the width of the river. So what I know right now, I know the entire distance. I also know from cabin to river and from cabin to river. I need to find this piece right here, this little missing piece in the middle. That's what I want to know, okay? So what I'm going to do first is add up the things that I do know. I know that one of them is this far from the river, and the other one is this far from the river. And so I'm going to put these two polynomials together so that I have one polynomial to represent their distances together from the river. I don't have any x's other than this 9x, so I'm going to put my 9x. But I do have numbers, so I have 1 plus 4, which happens to be 5. And then I just have this one random 3x squared. Now that is my polynomial in simplest terms. It is not, however, in standard form. Standard notation is to write them in order from largest exponent to smallest exponent. So in the proper order, it would be 3x squared plus 9x plus 5. These are the same thing. I don't care which one you write down. If you write this down and stop, that's cool. I'm not going to count it wrong and tell you, nope, you did this wrong. But this is how you would see it if you were going to answer a question on a test and were multiple choice. They would write it like this instead of like this. You just got to be able to transpose. Now, we're not done, though. This is just the distance from the cabins to the river. To find out this missing piece right here, I'm going to have to subtract their distance from the river from how far apart they are all the way. So I'm going to write it down here. This goes with part A. So this is my total distance. I need more space than that. So let's fix this so I have plenty of room to do what I need to do. So my total distance across the river is 12x squared minus 7x plus 5 feet. That is all the way across from cabin door to cabin door. My two cabins are sitting this far from the river, their total distance. And if I subtract these two, it'll give me the distance just for the river. So we're going to do like terms with like terms. So I have 12x squared minus 3x squared. Well, 12 minus 3 is 9, so 9x squared. You are subtracting. Do not do anything with your exponents. You're just subtracting. I'm just finding a total. I'm combining the two things. You only start doing weird things with exponents when you're multiplying and dividing. Now I also have negative 7x minus 9x. Well, negative 7 minus 9 is negative 16x. And if you don't believe me, type that in your calculator. That's what it equals. And then I have 5 minus 5. Well, 5 minus 5, they just cancel each other out. And so this is my distance across the river. From one side of the river to the other is 9x squared minus 16x feet. So that's the distance across my river. So that's your answer to part A. Now part B wants the width of the river if x equals 3. So I just got to plug in x equals 3. So I have 9 times 3 squared minus 16 times 3. Order of operations says you have to do the exponents first. Don't you dare do 9 times 3 and then square it. That does not follow the order of operations that you learned back in 6th grade. So follow your order of operations. Exponents first. So I have 9 times 9 minus 16 times 3, and I'm going to do that's 81 minus 48. And when I subtract 81 minus 48, I get 33. So my distance across the river is 33 feet. Those are my units given in my problem. Make sure you put them on your answer. So now let's talk about the fourth problem. Oh, I lied. There's really only 3 problems. It just says number 4. So this one is a shaded region problem. The reason it's on here is because it involves circles when we haven't had circles before. And so we need to talk about that. We're still going to do it like we have done. I got to find the area of the whole figure and subtract the area of the part, whatever the little pieces are. So the whole thing minus the not shaded part. So let's do the whole thing. The whole thing is a rectangle. So if I find the area of the whole thing, I have to do length times width. So I have 4y times 10xy. These are not polynomials. There are no plus or minus signs here. You are just simply going to multiply things together, and since I'm multiplying, that means when I do exponents, I get to add them up on this one. Okay? But this is not a polynomial. Don't try to do the double distributive thing. That's not what's happening here. You only get to do that when there are plus and minus signs present. So we're just going to multiply. 4 times 10 is 40. There's no x here, so I just bring down my x, and then when I do y times y, it's y squared. That's your area for the whole thing. Now for the part, I have these 2 semicircles. And if you know anything about semicircles, when I put 2 semicircles together, it makes one whole circle. So I'm really going to find the area of a circle, is what I'm going to do. So for the part, I have to find the area of a circle, which if you do not remember the formula, is equal to pi r squared. We're going to leave pi as pi. We are not going to turn it into a number. We are not going to write 3.14 or 22 over 7. We're going to leave it as the symbol pi. Our answer is going to be in terms of pi, which means that the pi symbol is going to be in my answer. Makes it so much easier than trying to convert that into a number, okay? So, I'm going to do pi times the radius. Well, the radius is half of the diameter, and it looks to me like my diameter is 4y. So my radius is 2y, and I have to square that. Now this is a power to a power, so I got to distribute my exponent. So I end up with pi times, well, 2 squared is 4, y to the second power. And so in terms of pi, this is going to be 4y squared pi. I'm just going to put the pi at the end. You can put the pi at the beginning. I do not care, but put it in there somewhere, okay? And in order to find the shaded area, or the shaded region, I'm just going to subtract those 2 things. So it's going to be 40xy squared minus 4y squared pi. That's your answer. You're not going to do anything else with it because you don't have any like terms that you can combine. That is your answer. Don't go try to make it more complicated. So that is applications. It's pretty much a review of what we've done, but I feel like some of y'all kind of needed it anyway. So we will practice this when you come to class, and I will see you tomorrow.